combinatorics is just like a fancy way, like the word combinatorics, just in case like if some of us are not familiar with what that means. It just basically combinatorics is just consists of like counting a probability. And counting a probability is like are questions that involve like, oh, counting like, how many ways are there to do something, or like what is the chances of this thing happening. It's like calculating how many ways to do something, or like, like finding the probability of something happening. Like that's what combinatorics tries to answer. So today we're going to be talking about like one of the most fundamental combinatorics techniques, which is called casework. So casework is not a very like advanced strategy, but it is a very powerful strategy to like solve many of these combinatorics like questions basically. So the idea of casework is like you want to take a complex problem and you want to split it up into like easier but smaller like sub problems kind of, and then you take each case separately and you calculate the result, and then at the end you add up all your cases to get the final answer. So I think casework would make more sense if like if we went over a few examples together that can be solved with casework, because I think casework, being good at casework, or like improving, is like really important by doing problems. Like it's very important to do problems if you want to like get better at casework. The first example problem says find the number of pairs of positive integers x, y. So x and y are positive, and they're positive integers, such that x cubed plus y is less than 50. So x cubed plus y is less than 50. So basically, to like solve questions like these, you would have to use something called casework. So if you're not familiar with casework, hopefully this example will make it more clear. So the idea is like in counting questions, like one of the main challenges in combinatorics questions or counting questions is being able to count everything like exactly once, like only once, and being able to count everything correctly. Because in combinatorics, it's very easy to like accidentally miss a case, or like accidentally, like overcount something, or like accidentally, like, I don't know, there's a lot of things that can go wrong in the process. So casework gives us a nice organized way to systematically, or not systematically, but like kind of just solve these problems in a more like organized fashion that will like decrease your chances for mistakes. So in this question, the idea is you can do cases. So you can do casework based on the value of x. So what this means is like we can look at the possible values of x, and for each possible value of x, we can look at what are the possible values for y. So the first case is x is equal to 1, right? That's the smallest possible value x can be. So if x equals 1, or let me just make it more clear. So case 1 is when x is equal to 1. In this case, then you have to have 1 cubed plus y is less than 50. So you got y is less than 49. And this gives us 48 possible values of y. In this case, y is less than 49 and y has to be positive. So that's our first case, basically. Our second case is when x is equal to 2. So in this case, you would have 2 cubed plus y is less than 50. So that would give you 2 cubed is 8. So 8 plus y is less than 50. So y is less than 42. So that would give you 41 possible values of y. If y is less than 42, there are 41 possible values. And our final case is if x is equal to 3. In this case, if x is 3, then you would have 3 cubed plus y is less than 50. 3 cubed is 27. So 50 minus 27 is 23. So y has to be less than 23. So there are 22 possible values of y in this case. And we know we can stop here, right? We don't have to go on to like case like 4 or something. We don't have to say case 4, x equal to 4, because like this is not possible. Because if x is equal to, that looks really weird. Because if x is equal to 4, then like 4 cubed is already 64. So 64 plus y, like if y is positive, then 64 plus y there's no way it can be less than 50. So that means we can just kind of disregard this case, like, and like just ignore all cases like after that. So we could just kind of like ignore that. So we only have to consider these three cases when x is 1, x is 2, and x is 3. So now to like finish the problem, we add up all the numbers that we got in our three cases. So we got 48, 41, and 22. So to get our answer, we would just add up the three results together to get the final answer. So you would just do 48 plus 41 plus 22, which is equal to 111. So basically, again, I think this demonstrates like how casework works pretty well, because like the idea is, and one of the main challenges in more complex like casework problems is the identifying what cases you should split it into. Like this time it wasn't, I don't think it was that like difficult to notice that like maybe splitting the cases based on the value of x is a good idea. So in that case, this gave us an organized way to count it. And just another note, just in case, like, because this might be a question, like maybe some of us might be wondering, why didn't we do like casework based on the value of y, for example? Like, why didn't we say like case 1, y is it 1, case 2, y is 2? Why did we choose x instead of y? So the reason we chose to do casework based on x is because, like, as a typical rule in combinatorics, you want to like mathematicians are lazy people, so like you want to like find a way to do the problem with as few cases as possible. If you did casework based on the value of y, then y can be anything from 1 all the way up to 49. That means you'll need 49 cases. On the other hand, if you did casework based on x, we see that this is like an x cubed, and x cubed grows much faster than y, which is why we have significantly less cases, which is why we did casework based on x instead of y.